surface areas?
No, just mostly finding volumes for cylinders and pyramids and all that stuff.
I see you sent me something here. I was going to pull up something that another student sent me that I figured. Are all four of these pages?
Well, it's only certain problems on certain pages, but
Okay.
yeah.
Okay. Let me make sure I get them all on my computer here. Sure, we probably aren't time to cover all of this. I apologize for being a little.
Yeah.
Sometimes it's tough for me to get out of a session, but I can go 5 minutes over. That's the instructions there.
Yeah.
Okay, I'm going to close this one out and let you tell me which ones you want to look at.
All right. I just want to make sure that I get the basics for each kind of structure. You know what I mean?
Volumes are actually easier than surface areas by a considerable amount. The reason is the volume is the area of the base times the vertical height. Let's always start with the general formula.
Okay.
Area of the base times the vertical height. It's that simple. And capital B means it's an area. It's not a linear motion. In other words, if I have a rectangle and I say B is the base and that's the height, that's a different B. That B is measured in inches. This B, being a capital B, is measured in square inches. So when you see a capital B, it means the area of the base. Okay? And it doesn't really matter what kind of base you have. If it's, well, let's take a couple of situations. Let's take a right cylinder. That is a prism. Okay? Soup can. It's a prism because I have a circle on top and it's opposite a circle on bottom. They're the same circles. They're parallel and equal. Therefore, this is a prism.
Okay.
Whenever you have a prism, the volume is equal to the area of one of the bases times its height. It's that simple. And it doesn't even have to be a right cylinder. If I had a cylinder that looked like this, as long as those things, those two circles are equal, then it's whatever that vertical height is. Still the area of the base times the vertical height. Okay? So as long as you're talking prisms or things that look like prisms, kinda, it's a simple formula like that. Now, if somebody gave us a sculpture or somebody gave us a soup can made of wax and they said turn it into a cone, I've got to shave 2/3 of the material off.
Okay.
Which means the volume of the cone is what?
1/3 that of the cylinder.
Exactly. And it doesn't matter whether it's a cone or it has a square base, as long as it goes to a point, you're shaving 2/3 of the material off. So the area of this square pyramid is 1/3 the area of the base times its vertical height. You with me?
Okay. Yeah.
So that's a key concept. If it goes to a point, you lose 2/3 of the volume, which means the remaining volume has to always be 1/3.
All right.
Okay. Now let's look at some of these problems. So let's find the volume of the solid in number 3.
Okay.
So what's the general formula?
Shoot, what is it? It was
Goes to a point.
was it 1/3?
Yeah. So you know it's going to involve a
1/3 base times height.
Correct. Capital base times height. Capital B meaning the area of the base. Okay, what's the area of the base in number 3?
The base is. It looks like it's a right angle, so it's 5 by 5.
Correct.
Yeah, and they tell you that
It's
too.
a square because they have a hash mark there, one there, one there, and one there. So we know all 4 sides are equal. Okay, so the area is 5 times 5, which is 25. What's the height? 6.
Yep.
Our volume is 50. Sure, hold on.
Okay.
My graphing.
Yeah.
My graphing tablet is going nuts here. Let me start it up again. Okay. So these are going to be relatively simple. What's number 4 going to be? Start with the...
Number 4 will be. Okay. Yeah. That's the
What's the area of the base?
equation for that. The area of the base is pi r squared, so that would be 10 squared is 100, so pi 100
100 pi
times 13. Yeah, 100 pi times
13. So the total volume is going to be 1300 pi divided by 3. Okay, so you can kind of see that these are really much easier than surface area. So all I need is a vertical height. And the vertical height on some of these solids, if they're regular pyramids, the vertical always drops to the middle. So I don't have any problem telling me that the vertical height there is 13. And same thing on number 5. It's a little harder to see number 5 because the base is a rectangle, but everything else is the same. The vertical height is just 4 inches. Notice that that vertical height goes from the vertex to the center of the rectangle.
Okay.
Okay. So it's going to be the area of the base, 2 times 5, 1/3 of
which is 10.
10 times 4.
10 times 4 is 40 divided by 3, so that's
40 thirds.
Yeah.
Cubic inches. Volumes are always cubic measurements. Okay, now let's look at number 6. 6 is different in that it's not a right cylinder. That's a right pyramid. In other words, the vertex drops right in the center of the thing. Same thing with that, same thing with that. But this is like a slanted dunce cap. But it doesn't matter. It's the same formula. It's still 1/3 the area of the base times the vertical height. And we know the vertical height there. So,
will they ever not give you the vertical height?
Well, yeah, they might. They might not give you everything you need to plug directly in. For example, number 8.
Okay.
Not number 6. 6 is easy. It's pi times 2 divided by 3. It's 2 pi divided by 3. Okay. Number 7, that's also not a I'm not sure what the word is, a regular polyhedron. Doesn't matter, is all we need is the area. What's the area? That's a triangular base in number 7. What's the area of that base?
For a 12, so that's 6 inches cubed, or 6 inches squared, I guess.
Well, right. Times the height, which is 3,
Yeah.
divided by
So that's 18 inches cubed divided by 3.
right. So we have 6 cubic inches is the volume of that figure. Now, 8's a little tougher because, first of all, we need to figure out the area of the base, right?
Okay.
They don't give us much there. They give us the vertical height, but there's a lot of work to figure out the area of the base. What kind of base is that?
The base is a hexagon.
Correct.
But it's a regular hexagon.
It is a regular hexagon.
So it's easy to find the polygon.
So what's the area of a regular hexagon equal to?
360, yeah, I guess that's correct.
Well,
From the middle
it's
is 3.
formula. Remember that? The area of regular polygons is 1/2 the apothem times the side length times the number of sides. Okay? Well, they haven't given us the apothem. They've given us a side length of 12, but we need the distance from there to there. That's the definition of apothem.
Okay.
Well, we're going to have to do some geometry to get it. If I look at that triangle right there, what are my measurements? What is that central angle of that triangle?
60 degrees.
Correct. So after I drop my apothem, that's an isosceles triangle. That, therefore, must be 30 degrees. Now, let's draw that triangle all by itself so we can analyze it a little easier. I know that's 30. What's this side down here?
That's 6.
Okay. Now I can solve that triangle. Let's go through how we're going to make sure we solve that 30-60 right triangle. Remember how I told you that you're going to run into this triangle so many times it's going to make you sick. What are the dimensions of the basic unit 30-60 right triangle? What's opposite the 30?
What do you mean?
Well, I call it my unit. If you have those dimensions memorized, then you'll be able to figure out what A is over here.
Okay.
These two triangles are similar. So all I have to do is figure out the similarity ratio. What is it?
Square root of 3.
No. Make sure you're measuring the proper sides. In other words, over here I'm looking at the side that's opposite the 30-degree angle. And over here, the side that's opposite the 30 is 1. That's why I call it my unit special triangle. So what's the similarity ratio?
Okay.
How much bigger is this triangle than this? Side?
6 times.
Exactly. So the side opposite the 60-degree angle, which is my apothem, must be what? Has to also be 6 times this measurement.
Okay.
6 root 3. So whenever you're asked to solve a 30-60 right triangle, as long as you know that one, then all you have to do is figure out the similarity ratio, and you can put all dimensions. What's this hypotenuse got to be? Not that I need it.
12.
Right. It's 6 times this hypotenuse, because that similarity ratio is 6 to 1. That's a linear ratio. but I don't need that. As all I need is that measurement. That tells me that measurement is 6 root 3. Now I can figure out the area of the base. So the area of the base is 1/2 the apothem, 6 root 3, times the number of sides. There's 6 in a hexagon, or the side length is, the number of sides is n. Now let me write these in the right order. Side length is 12. Number of sides is 6. So that's the area of the base. And let's see, what is that? 72 times 3, 216 root 3. That's the area of the base. What's my general formula for volume of this? In other words, we had to do a whole lot of work just to find the area of the base. But
it's generally area of the base times height.
Divided by, because it goes 1/3.
Oh, divided by 1/3, yeah.
Right, 1/3. I don't even like to say divided by 3. I prefer to say the volume of a pyramid is 1/3 the area of the base times the height. Just like the area of the hexagon was 1/2 times the apothem times the side length times the number of sides. I like putting that fraction up front because you'll forget it less often that way.
Okay.
When you say divided by 3, it's really easy to forget that and end up just using base times height. Okay, well, I know my area of my base is that. My height is 17, so I have 216 root 3 times the number 17 divided by 3.
Okay.
And that is 72. So it's 72 times 17 times root 3 is your answer for number 8. So the degree of difficulty on these problems, really, they won't always give you this vertical height. Sometimes they'll give you a slant height. Okay, and if they give you a slant height, that's very useful for doing surface area because your equations, their general equations are based on slant height. But when you're doing volume, you want vertical height. So if they were to give us a slant height, we're going to have to create some triangles to figure out what the vertical height would be. But in none of these problems do they give you a slant height. So all of these are, the first 5 of these are extremely straightforward. This is the only tough one, number 8, because we have to figure out what the area of that hexagon was.
Okay.
All right, we got time for maybe one more. Do you want to switch to a different page? These bottom 3, they're just, they give you, it's the same problem, only they give you the volume and they ask you to solve for the vertical height.
All right.
Or they give you the volume and they ask you to solve for the radius. Or they give you the volume and they ask you to solve for vertical height. It's just a different variable they're asking you to solve for.
Okay, and you just kind of reverse the process for that, don't you?
Let's do one of them. Let's do 12.
All right.
Always, always, no matter what the geometry problem is, start it with this. Always start with your general formula. Because now we can just take all the information they gave us and plug it into this. Well, what they told us the volume is 200, so I can plug that in for V. Do I know the area of the base?
No, but you can easily find it.
10 times 10.
It's just 100 centimeters squared.
It's 100. It's 10 times 10. The height is x. So now I just have to solve that equation, which is easy. x equals 6.
Yeah. Mm-hmm.
So that's how you do each of these three on the bottom.
All right.
The
That's
middle
pretty
one,
simple.
the middle one, yeah, it's fairly straightforward. As long as you start with the general formula on all of these, this is just slightly more complicated. Let's just look at this one. Tell me what I should write next on third.
So we can plug in the height. We know that's 18.
Okay. Well, let's start from the left
And
to the right. What's the volume? They give us that, 216 pi.
Yeah, and then 1/3 capital B, and then 18.
Okay. So we can solve for the area of the base, right?
Yeah.
But that's not what they're asking for. They're asking for the radius. So let's be a little more specific on the area of the base. That's pi r squared, right?
Yeah.
Okay. Now we have an equation that only has one variable. It's r. And we can solve for it. We can
eliminate the pi's.
cancel those. Simplify that. Divide both sides by 6. I get 36 equals r squared. What's r equal to?
Okay. R is equal to 6.
And that's x. That's what they wanted you to solve for, was r. Okay? So, long as you start with that and just fill in everything they gave you, you might have to convert that capital B to what it is. When it's a cone, it's pi r squared.
Okay.
Okay?
That makes sense. Yeah.
14 is only tough because that base is an equilateral triangle. And they've only given us one side of that equilateral triangle. So figuring out that equilateral triangle is not that easy. They actually, in their book, they give you a formula for the area of an equilateral triangle, but we don't really need it. As long as we know that, we can always drop a vertical. Now we know this side is root 3. That's a 30. That's 60. So now we can figure out everything we need to know about the base and the height. Once we calculate the height, we'll know how to figure out the area of that triangle.
Okay.
Okay. Once you get the area of that triangle, they give you the volume so you can solve for the x, which is the vertical height.
All right.
Notice this is not x here. What I've done is taken the base and laid it out in an equilateral triangle. Just, in other words, the problem with all of these is solving for the base. Right? I mean, all of them, the height was easy. The difficulty is always in solving for the base. But if you're solving an equilateral triangle for a base, you know that it's relatively easy because the vertical splits the base and it leaves you with a 30-60 right triangle. And so you have to solve that right triangle. Similarly to the way we solved the other right triangle. This is a little tricky. Let me just ask you one question. Here's our basic right triangle that I call my unit right triangle. This right triangle there, what's the similarity ratio? You have to find corresponding sides. You do that by looking at what's the side opposite the 30-degree angle in both cases.
It's 1 to square root 3.
So big to little is what ratio? Square
I'm
root
not
of
sure.
3 to 1. Square root of 3 is bigger
Okay.
than 1. Okay? So the bigger triangle relative to the smaller triangle, corresponding sides is a square root of 3 to 1 ratio. Well, what's that make this dimension right here?
Would that be square root 3 times itself, or?
Very good. Which makes it what? What is square root of 3 times square root of 3?
Square root 9.
Which is?
I don't have my calculator out for that.
Square root of 9 is 3.
3.
You don't need your calculator to do
Okay,
square
that
root
makes
of 9.
sense.
But also, the square root of 3 times the square root of 3 is 3. The square root of x times the square root of x is always x, no matter what it is. Square root of 17 times square root of 17 is 17.
All right.
Okay, so now we can figure out the area of that triangle. It's 1/2 the base. Well, the base was 2 root 3 times the height, which is 3. 3 root 3 is the area of that triangle, of that base. So it's 1/3 area of the base times x is the height. And all of that's equal to that volume they gave you. You're going to be able to solve for x easily. In fact, I think x comes out to be 7.
All right.
All right.
That makes sense.
Yeah, that's a good set of problems to cover. That covers a lot, doing those problems we did. I'll hold on to the rest of your documents in case you want to go over some of them on Thursday. But for now, I will talk to you later.
All right. Thanks, David.
Okay, Mark. Bye-bye.